My name is Joe Holliday, and I'm a professor here, and I teach geology and oceanography, the advisor to the Science Club. I developed this topic because I took my sabbatical 2 years ago on global warming. And my other job that I have during the summer is I work for National Geographic as a naturalist, and it's the world's second best job after this one. And because of my connection with National Geographic, I got to go to places like Antarctica and the Arctic Ocean and the Galapagos Islands that most people can't afford to go to, including myself. And so that's a lot of this research that you're doing here today is thanks to the National Geographic Society helping me out during my sabbatical. The topic of this discussion is on global warming and global climate change. As we go through our lifetime, there is an unarguable progression. The 9 out of the 10 hottest years of all time have been the last 9 years. And 19 out of the top 20 have been in the last 20 years. This is happening. There's no question about it that this is happening. It doesn't matter whether you go to the Arctic or you go to the United States or England. It doesn't matter where you go. It's happening faster at the poles. So that's why I traveled to the poles, is to see firsthand this progression. And what's the cause? The cause, as every earth scientist believes in, is humans producing a surplus of CO2. We have this huge surplus of CO2. It's coming from not just our cars, but also our power plants. And it's equal blame. It's about 1/4 cars and trucks, and about 1/4 other transportation like trains and planes and boats, and about 1/4 power generation, and about 1/4 other things, including deforestation of our rainforest. So the combination of all 4 things is pretty dramatic, as you can see here. It happens to have started right at the beginning of the Industrial Revolution. You can see in around 1850, the Industrial Revolution took off in the United States and Northern Europe. But the rest of the world really didn't get industrialized till around 1900, places like Italy, Germany. And now, of course, you're all familiar with China and India being industrialized. So the chart is parabolic, going up faster and faster. What does CO2 do? CO2 is the same stuff you're breathing out. It's harmless. It's to plants. Plants love it, right? Plants just soak it up and turn it into oxygen. And it's colorless and odorless, and it doesn't hurt us directly. It hurts us indirectly because it acts like a blanket, and it's an invisible blanket, like a thermal blanket. And what happens if you go to bed at night, you have one blanket on? What happens if why don't you have 4 or 5 blankets on? You get too hot. And then so imagine putting a blanket on every year, and that's but an invisible blanket, okay, like an invisible cloak. And that's what's happening. And what happens, it happens no matter how much CO2 there is in the atmosphere. The sunlight comes through, and it hits the pavement outside, and it reflects back heat or infrared radiation. And then that's what the CO2 traps. Okay. And also methane. But CO2 is the big one because it's increasing so dramatically. And you've probably never seen a greenhouse, but greenhouses have been around for hundreds of years, and they take advantage of that. If we name this effect now, we wouldn't call it the greenhouse effect. What would we call it? We call it the car window effect, because almost everybody in the industrialized world knows that car windows allow visible light in, but they trap the heat. And this is all invisible, remember, and it's all in the chemistry of the atmosphere and the physics of CO2 and methane. And this shows the light, visible light coming in, the same light that we see coming in, no problem at all, except maybe on a cloudy day. And then it gets trapped, shown by these red arrows. All right, the consequences are overwhelming. It's way too much to talk about on this slide, but I'm going to be covering these in this talk. I'm going to be talking about the changing climates. It's more than just global warming. It's called global climate change for a reason. We'll start out with the warm, fuzzy creatures that everybody likes, and you can get emotionally involved, right? And that is, we'll start out with penguins. When I was down in Antarctica, I studied I went to Palmer Station, which is a U.S. research station, and looked at their research having to do with several things. One has to do with penguins. The penguins on the right are called Gen 2 penguins. And to you, they probably look like the ones on the left, but they're totally different species. They have totally different ecosystems and different behaviors and different mating behaviors. The Gen 2 penguins are winning out over the penguins on the left. The penguin on the left is called the Adelie penguin, and the Adelie penguins are losing the battle. Why? Because they're adapted for very cold Antarctica type climate, and it's warming up. It's warming up much faster in the polar regions than in the semi-polar regions. So the Gen 2 penguins are like humans taking over from the, I don't know, the chimpanzees or whatever. It's a major blow to the Adelie penguin on the left. Okay. Something that affects us here locally is the reason why our oceans are so rich with fish is we have what's called upwelling. And coastal upwelling is what we have along the California coast. But we have other kinds of upwelling out in the open ocean, particularly in cooler areas like around Antarctica. Like this upwelling brings up nutrients from the seafloor, shown by those black arrows. It brings up nutrients, things like nitrates and phosphates, and that the algae live on the surface, and they need the nutrients in order to grow. And if they grow, then the little animals can eat them, and then the fish can eat them. So you have lots and lots of fish, and lots of whales, and lots of killer whales and penguins. But if something stops this upwelling, or even slows it down, then it's harder time getting the nutrients up to the surface. And that's what is happening. And this is a scary thought here. This happens every 5 years or so in California when we have an El Nino. That's a natural cycle. But imagine this happening all over the world. It would create way less algae. With less algae, with less animals, and you get less animals, you have less fish. You have less fish, you have less whales and penguins and tourists or whatever. And so it's something to think about. It's not just about the warming atmosphere. It's about the warming ocean. The animals that are affected by this, that are the warm fuzzy creatures, the charismatic megafauna, are the ones that tourists go to see, like humpback whales and killer whales and seals and sea lions. This is impacting now jobs, right? There's a lot of tourism in Alaska, the wildlife. And if there's less wildlife, it's going to impact jobs. Same with Antarctica and Galapagos. That's the only reason people go there, usually is to see the animals. Okay, now I'm going to go on to the land. If you're talking about mountains like Colorado or Himalayas or any mountain ranges, on every mountain range, there are species that have adapted for that over thousands of years. Since the last ice age, we've had a climate change that happened about 10 to 20,000 years ago, but it happened slowly. Species can adapt. They can move. Animals, like the cute pike on the left, can move. Plants can move by seed dispersal, and wherever there's seeds. Land, if they can grow, they start germinating and growing. But if this happens too fast, the animals have a harder time at it. So an animal like this, pike could move, right? It could just keep going as the climate warms. It can go up the mountain, or every generation goes a little higher up the mountain. The same with the plants. The problem is the mountains aren't infinitely high. Eventually, what's going to happen as the climate warms up, they're going to run out of space, right? And this is already happening. There's already documented proof. There's hundreds of researchers that are working on this, and this is a scary thought. I spent a month up in the Arctic Ocean in Svalbard, and the big fear there is all the species of plants that live in Svalbard have no place to go. That's like the coldest place in the northern hemisphere. Right. This one's more complicated, but you can handle it. This is the idea that animals aren't just by themselves. They just don't sit around munching food like we do at McDonald's. They migrate. Fish and sea turtles and birds all migrate. And they migrate from where one food source is to where another food source is. The phenomenon is they arrive about the same time their favorite food is hatching or whatever. So in the case on the left, of course, you have a famous robin representing all the bird species. And when they migrate, when they arrive at the same time that the worms are starting to reproduce, and the same time the insects are reproducing and starting to grow in springtime. In the case of where I go a lot is up in Alaska and the Arctic. All the birds up there migrate up there, and they arrive during their spring. It's a little later. The salmon of Alaska and other places, they arrive in summer and fall, but they arrive, why at that time of year? Because the stream version of insects, the little isopods and arthropods and all those other pods, are all at their maximum population at that time. The problem is, some animals migrate by sunlight, and some animals migrate by temperature. So which one of those two is changing? The temperature one's changing. The birds are arriving earlier and earlier, and on the East Coast in particular. Certain insects and certain animals are doing it by sunlight. Sunlight's not changing, but the temperature is changing, so the cycles are off. And that's what animal researchers are working on and worried about. Okay, here's another one. You think, oh, nobody could touch a grizzly bear, right? They're the scariest animals. But there's a big discussion on whether to have them be on the endangered species list, because the grizzly bear inland, so we're talking about in the Rocky Mountains and in Canada, their main source of food is not humans. Okay? It's not animals. Their main source, they get over 90% of their food from vegetable matter, things like berries and nuts and everything. And so they're in great danger because in the Rocky Mountains, their main source of food are the nuts from pine trees. And the problem is the nuts are decreasing in their population. Why? Because the pine trees are being attacked by beetles. Okay. Why? Because the growing season is longer. And very complicated. But it's fascinating, I think, the fact that because we have warmer temperatures, we have longer growing seasons, and you think, oh, that's all good, we can grow more crops. But the problem is insect pests like pine bark beetles and spruce budworms are also having a heyday, and they can start killing vast populations of trees. And you think, oh, who cares about trees? Well, certain animals rely on trees. And that's just only one of them. There's lots and lots of, there's like stellar blue jays and pine cones, and squirrels rely on them. You don't care about animals, maybe you care about humans, okay? What's the biggest killer in the world of disease-wise? Malaria. Malaria. Kills more people than car accidents and everything. It's rivaled only by cigarette diseases. But for insect-borne diseases, there's no question that malaria is the big bad one. And we're on the cusp of getting rid of it with mosquito netting and drugs and things like that. But the problem is with global climate change, the mosquitoes that carry malaria are temperature sensitive. They can't live in under 40 degrees. Right? So as the world gets warmer, what do you think? More or less land? More land. And notice the United States is on that map, right? So purple and green, and the rest of the eastern United States can get it. It just is temperature dependent. The other thing mosquitoes need is water. As you warm up an ocean, particularly, 70% of the earth is covered by ocean. And what can happen to the amount of evaporation off of the ocean? It's going to increase. It happens. Every time we have El Niños, every 5 years here, we know we get twice as much rain. Well, this is like a slow motion version of an El Niño, but covering the whole world. Not just every 5 years, but constantly. Every year, the ocean gets warmer and warmer, and there's more evaporation, and therefore more rainfall. Not every place is going to have more rainfall. And the most powerful computers on Earth are these supercomputers at research centers, and they can crank the numbers for like a whole week, and what they come up is wet places are going to get wetter, and dry places are going to get drier. Okay, so where do mosquitoes live? In the wet or dry? Wet. So the wet places are going to get wetter. It's going to be harder and harder to fight malaria. Just as we're so close to getting rid of malaria, this is going to set us back. So I have to throw in one, I didn't want to depress you. But we ran out of gas one day and I had to pull the boat through. So, 10 years of college to pull a boat. Here is another issue having to do with the ocean, and the press does not like to cover this book. I think I've only seen one article on this through the years, and because they consider it a little over people's heads. But it's quite simple. If you add CO2 to water, like you do to soda pop, beer, champagne, whatever your favorite bubbly drink is, as you add it, it adds acid. And how many of you knew that? Soda pop and beer is acidic, okay? It affects your teeth. It's acid. Well, our teeth are not the problem. The problem is the most dissolvable substance in earth science or biology is calcium carbonate. And it just so happens, by really bad luck, that calcium carbonate is the #1 seashell material in the whole world. It makes all the seashells you pick up on the beach, coral, and a lot of the plankton out there. This has nothing to do with the temperature, right? This has nothing to do with drought or more evaporation. This is a whole new subject. As the amount of CO2 is put into the atmosphere more and more every year, half of it is being absorbed by the ocean, and the ocean plankton are doing a really good job of turning it into oxygen. The estimates are half of all the CO2 we're putting out is being turned into oxygen by the ocean algae, but there's still too much going in. And so the ocean is getting more and more acidic, and as it gets more and more acidic, what's going to inevitably happen to organisms with calcium carbonate shells? They're going to dissolve. And it doesn't mean they're going to dissolve and poof, disappear. What the studies are showing, and here again, there's hundreds of people working on this and for PhDs and research grants and stuff. It shows that it's not that they're dissolving and disappearing, it's that they're spending more and more of their energy trying to put out the shell, protect them. So they're less and less energy to do reproduction, less and less energy to be growing. So the studies are showing they're just stunted. You end up with a bunch of small coral polyps or a bunch of small clams. And this is easy experiment to do, right? Part of science is to do experimentation. This is easy to do. Almost every research facility in the world is doing this. You just simply put more CO2 in the tank of water and see what happens. And you'll see that the oysters only grow half the size, and the clams only grow half the size, and the coral starts having a problem. The coral reefs are some of the biggest tourist attractions in the world, so that is an impact on the economy, right? So as the coral reefs have bigger and bigger problems, less and less tourism. But the scarier thought is that more than half of all the algae in the world has calcium carbonate shells. So that's the basis of the food chain. Here's a totally different subject. We're going to go back to warming. As it's global climate change. It's not just the atmosphere that's warming up, the ocean is also warming up. And as it warms up, little things start to be affected. And what we're most afraid of is positive feedback loops. Okay? And so I want to explain. A positive feedback loop in anything in nature or industrial, such as a nuclear meltdown, something like that, or a nuclear bomb. Positive feedback loop is the thing we most fear because it's something where once you get it started, it becomes self-perpetuating and gets worse and worse and worse. And here's an example of a positive feedback loop. As the oceans get warmer, they start to release what we call hydrates. And what's a hydrate? Gas hydrate is how when natural gas seeps up out of the seafloor, it's so cold and under so much pressure down at the bottom, 3 miles down. It doesn't form a gas, like forms something that looks like ice, except it's more like dry ice. Have you ever seen dry ice? Dry ice turns directly into a gas if you have it out. And that's what this is. This is a methane version of dry ice. As it warms up, more and more of the methane will be released, and as it gets released, it goes into the atmosphere, and you think, oh, no problem, there's more methane in the atmosphere. Well, methane is the second biggest global warming gas, the second biggest greenhouse gas. If we start having it coming out of the ocean all over, you can see it's all over the ocean, then it's much worse than having a billion cows belching methane. right? Methane is 30 times more effective as a greenhouse gas than CO2. So methane is a scary gas. Okay, it's not the big one that we're producing in mass quantities as much as CO2, but it's the one that I think we have to watch out for and keep our eyes out for. Do you think any researchers are working on this? Oh yeah.